Hello friends, after we have discussed the Ohm's law and resistances, we were able to solve the series and parallel combination of resistances. We learned how to find the equivalent resistances from there. But many students have asked how to solve this kind of which is called cubic frame wire or cubic mesh network. So how to find the equivalent resistance between the two diagonally opposite corners of a cubic mesh. So first of all, don't be scared because there is a pretty simple way to solve this kind of circuits. So for that we just let's assume a typical example on this where 12 equal wires, each of resistance capital R ohms, are connected so as to form a frame of cube. An electric current enters the cube at one corner and leaves from the diagonally opposite corner. So we need to calculate the resistances between the two diagonally opposite corners. So let's just name it here, like name it as A and this one as B. So we need to find out the equivalent resistance between A and B. So how to start this kind of things? So we know, if we consider the current entering from A is capital I, so the current will exit from B is also I. Okay, so as these resistances are equal, all are capital R, so this current will divide into three parts here. One is I by 3, I by 3, and here also I by 3. Now after this, in this point, this I by 3 will again divide into two equal parts because these two resistances are also equal, R and R. So this will become I by 6 and I by 6. Likewise here this I by 3 will divide into two equal parts of I by 6 and I by 6. And here also this I by 3 will divide into two equal parts, sorry, I by 6 and I by 6. Now what happens is, this I by 6 and this I by 6 will combine here to produce I by 3, and this I by 6 component and this I by 6 component will give you here again I by 3, and these two, this is I by 6, this is I by 6, so it will also give you I by 3 here, and this I by 3, I by 3, I by 3 will combine to give you capital I here. Okay, so let's just assume the battery voltage, the EMF of the battery is E, and the internal resistance is given as negligible, so we can neglect this one. So the potential difference between A and B will be equal to the EMF of the battery, that is E, capital E. Okay, so let's just consider one of the path between A and B. So let's just consider A to name it as C, this one is D, so A to C to D to B. Okay, so we are considering A to C to D to B. So what we'll get here, we will get from A to C, resistance is capital R and current is I by 3. So the voltage drop across this resistance, so voltage drop means VA minus VC will be I by 3 into R. Similarly, VC minus VD, that is voltage drop across this resistance, will be, so VC minus VD will be, this is I by 6, current is flowing through the resistor R, so I by 6 into R. And what will be the VD minus VB, the potential difference across this resistor will be VD minus VB is equals to, again, I by 3, current is flowing through the resistor R. So if we add up these three equations, what we'll get, VC will cancel out, VD will cancel out, so VA minus VB, that is our voltage drop or potential difference across these two points, diagonally opposite points, which will be equal to, if we consider R here, so in brackets we'll get I by 3, I by 6 and I by 3. So what you will get here, and VA minus VB is, what is this? Potential difference between A and B, which is nothing but the electromotive force or EMF of the battery or cell, because the internal resistance is 0 here, so no potential drop across the internal resistance. So we'll get E is equals to R into, what we'll get, 2I by 3 and then again 4, so 5I by 6 here. Okay, so let's just keep it for a reference, future reference. So we are getting here E is equals to 5I by 6 into R. So now if we remove this circuit with an equivalent one, so what we'll get, this is point A and this is point B. So if the equivalent resistance between this is R equivalent, and the current will be, current from here to here will be I, and the battery will be same as this one, E, with EMF E, correct? So from here what we'll get, I will be equal to, E, VA minus VB, or E is equals to I into R equivalent. So this equation and this equation, if you can see these two, we can write 5I by 6 into R will be equal to I into R equivalent. Okay, this one, fine, 5I by 6 into R, because both are equal to E, which is the EMF of the battery. So let's just write it here. This will be equal to I into R equivalent. So what will be your I will cancel out. So what will be your R equivalent? R equivalent will be, so equivalent resistance between these 2 points, diagonally opposite points A and B, will be your 5R by 6. This is your answer. Okay, so I hope you all have understood this type of problems, how to solve this one. If these resistances are not equal in nature, means if these are different, so we need to divide these currents accordingly, because here it is R and R, so we have divided the current equally, I by 3 and I by 3, and here I by 6 and I by 6. But if these resistances are not equal, so you just need to divide it in the correct ratio for that. Just only the difference is that. Okay, so I hope you have understood all the concepts here, and if you still find any queries or any other related queries or any other topic you want me to discuss, so you just mention it in the comment box, or you may directly WhatsApp me in my WhatsApp number, which is given below in the description box. So I will upload this solution also in the description. So please, if you like the video, please share and subscribe, and please press on the bell icon so that you don't miss any of the important topics in future. Okay. So let's meet on the next session. Bye bye.